Hello, my name is Anthony. I'm the Director of IT over at Oak Hill Collaborative, and this is another Makerspace Night at Home day. I decided to record a video instead of doing a live stream this time. That way I can deliver more of the same content consistently without having to worry about drops in bandwidth. So today I want to focus on project development. That's kind of a lot of what we do at Makerspace Night. Is we brainstorm ideas and we try to get them into this project-like format. And I think that there are 3 to 4 distinct, unique phases to project development. And to illustrate these phases, I'm going to be using a personal project of mine, which is my homemade Raspberry Pi laptop. So I have it here today with me in front here. It's all hooked up and whatnot. I'll be turning it on and showing it off later, so don't worry, you'll get to see how it runs. But to kind of illustrate these different phases of project development, I'm sure with how everyone's hunkered down and stuck at home now, you've got plenty of free time to do the first phase, which is brainstorm. Brainstorming, I think, is a very important phase of project development because it's where you gather everything that you need to begin at least thinking about what your project will really need. So you'll encounter the scenario of, I have everything I could ever possibly need, and then you run into a roadblock during actual project implementation, which is another phase that we'll get to, but you'll realize that you did not get everything that you needed. So it's hard to say when a planning part of the project development cycle is truly finished, because there's always going to be, going back and revising and trying again. I mean, it's the scientific method. It's hypothesis, test, rinse and repeat until you have a theory, that kind of idea. So with planning, you're thinking about what resources you're going to need. And this could be raw materials, this could be tools, this could be technologies or specific skill sets related to a technology, or create kind of like a creative skill, maybe like working a CNC machine or perhaps even a 3D printer, because you can have all the tools and materials in the world. They don't make the project themselves. You're going to have to learn how to put them together. So project planning is a good phase, and it's where you're going to start because everything else is dependent on the plan. You can't just go right into implementation without no roadmap. Otherwise, you're just going to be setting yourself up for disaster. So, well, once you've got what you think is a complete plan, like you don't want to spend all of your days thinking, oh, what if I did this? What if I did that? Because there is such a thing as over planning. You can spend so much time on planning a project and telling your friends, oh, I got this big project in the works. But if you never actually implement the project, what good's the plan? It's the proof of concept that really shows that you've developed a good plan, not how much time you've spent on it. So, well, once you feel you've got a solid plan, I know I keep sidetracking, but you kind of want to move into the formulation, kind of the first step of implementation, and this can be referred to by many phrases. I know specific areas of development have their own, niche phrase for describing this part of project development. Specifically, programming and video game development and web development may refer to this phase as prototyping, trying to build up a beta or an alpha into kind of a solid version 1.0. I feel that's a good mindset to have when developing something. You want to have a good idea of what state of completion you're in. That way, depending on your workflow, if you're doing multiple things at a time, you have one thing that's more dependent on another. You know when to start the next phase and really get your project on the road. So prototyping, get your prototype finalized where you think is a good stopping point, and then you've got presentation. Presentation is an important phase because it's where you explain to people what you put together, unless it's something that you feel is self-explanatory, where they will look at it and immediately understand what they're looking at. then maybe give them kind of like a little sales pitch at that point. But 9 times out of 10, you're going to describe what tools you used, the effort that you put into the project, so they really get a full picture of just how much time you poured into it, how passionate you are about your project. Because you can have a really weird or quirky concept, but it's the presentation and how you sell it is what can really make it go far. After presentation, you have revisions. You, while presenting, or maybe weeks down the road after your presentation, you're thinking to yourself, "There's something I could have done here differently. I could have moved this. I could have moved this on the blueprint over here, and I could have used this type of cable instead of this type of cable." Whatever the reasoning may be, if you revisit a project, you're going to notice that there were slight oversights in specific parts. And I'm rambling right now, but when I use my project as an example here shortly, I'll help use my project and have this make a bit more sense. So your revisions are just repeating the cycle all over again. You're going back into planning, you're going back into research, and you're kind of building your roadmap for what more can be done here. And once you've developed your plan, kind of your blueprint of how you're going to operate, that's when you go back into the implementation phase and re-implement or implement something completely new if you're adding additional functionality to your project. And then you present, and then the vicious cycle repeats over and over and over until you just don't mess with it anymore. But what good is a project if it just collects dust? So I always like going back and working on stuff that I've regarded as finished because, as I said, you're never going to find that it's 100% perfect. So let's dig into the meat of the bones here. Did that phrase make sense? I don't know. But what I have here is kind of sort of 75% complete laptop. Now I'm going to move the camera here so you can get a better view. And what we have here is a project I like to call Cutie Pie. The reason it's called this is because QT, cutie, it's small. And it runs off of a Raspberry Pi 4B. Pretty sure that's not in camera. There we go. It's a Raspberry Pi 4B. It's a 4 gigabyte board with micro HDMI, 3.5 sound, USB 3.0, gigabit Ethernet. It's a system on a chip, so it is a very, very small computer, all soldered to the same PCB. And what's up here is actually a two-piece bit of hardware. They're kind of dependent on one another. There's an LCD display here. It's I think a 7-inch display, and that there is hooked up to the video driver board. It's a computer board that is specifically responsible for translating the signals from this device into an output that can be viewed on the screen, and bridging that communication divide between the board and the screen. I also have a battery pack here that's used to power the screen when the battery pack isn't dead. Today I just have it hooked up to my desktop computer. That way I don't have it power off mid-presentation. And I also have a extension cable here that is USB-C, 5 volt, what have you. It's plugged directly into the Raspberry Pi, and I have a cutout here where the other end comes out. And I'm gonna plug this in, see if I can get it to turn on after a week of not turning it on. Fires up. Now you'll notice it's missing something essential. What do all laptops have? A keyboard and a mouse. Well, my solution for that, as temporary as it was, ended up becoming a permanent solution because I realized that building your own keyboard is a project in and of itself. So I have a Bluetooth keyboard and mouse pad here that serves the same purpose. Alright, so let's see here. Oh, I see. Computer's not on, so the screen wasn't receiving power. Alright, so now it's booting, hopefully. No signal. Oh, that's always a good sign. Alright, let me just reboot it. Now that the screen's receiving signal again. Because there it goes. The Raspberry Pi specifically has this thing that it does when it boots up, it reads its config files to tell it which display to output to. And if it doesn't detect an active display on one of its HDMI ports, what it does instead is go to its GPIO pins and just kind of assumes that there's a video signal there. Oh, it just turned off again. What is it doing? It's making me concerned, that's what it's doing. Alright, it's booting up again. Now, I'm going to have to actually hook up a mouse to this, because I don't think this this here Bluetooth keyboard is actually paired to it. Now, to describe my purpose here, why I did this, I had an idea. I'm sitting here thinking, well, I make desktop computers all the time. It's my favorite thing to do. I like to build gaming computers for my friends. I like to mess with server racks. I like to mess with really small computers like this one. I haven't really seen anyone build a laptop yet. So off of that pure motivation alone, I decided that I was going to try my hand at building a laptop. Now, that is not to say that it hasn't been done before. It's just that it's not really a streamlined process like building a desktop computer, where it's just a bunch of adult Legos that you snap together. This is a bit more, I wouldn't say complex, but it's unique because you get to kind of choose your own adventure, choose how you want to implement it, and that goes back to my description of planning, brainstorming. You got to figure out a game plan of how you're going to do things. Alright, so we're going to get Bluetooth. Come on. Add a device. There we go. Actually, I think it's already paired. We'll find out. It says that's already paired. Let's connect. Connecting. Make sure the video output's fine. Connection failed. Amazing. Don't worry, I'll just remove device, re-add it. You see, I saw this coming. That's why I hooked up a mouse to it. Alright. Pairing, add device, keyboard, pair, type. Alright. Successfully creating connection, and done. Okay. So, that is, we're going to plug this mouse back into my computer here, that way I don't forget about it. Okay, so, now the issue that I had with developing this is that it was not as pristine as this implementation is here. My first iteration of this did not have any form of actual dedicated power. Like, I didn't have a power supply in here. And what I did essentially was I used the Raspberry Pi screen that is sold by the Pi Foundation. I thought, oh yeah, that's good enough, and I didn't look into it any further. What you actually get is a similar setup to where you have a screen and you have a board, and then instead of using HDMI, it connects to the board using GPIO, which isn't a problem, except for when it is. And the problem that I encountered was the ribbon that comes with the screen that connects it to the board is super thin, so it did not like the laptop interface of being, you know, shut and closed over and over, because eventually what would happen is that the ribbon would snap. So and that was just one of the many issues of version 1.0 that I didn't really think of my first time, you know, brainstorming. Another oversight that I had when developing this is that this board wasn't over here on the side like this. It was actually over here with the USBs facing out this end. And while that wasn't as much of a problem as it was at the time, when I got this new screen, this new board, and I had to completely rearrange everything, it was just in a really awkward position because when I put it here, it only leaves me about this much space to implement my cabling, my power for the screen, so on and so forth. So that was one issue that I had, was the positioning of the board itself. Another oversight that I think I briefly mentioned, but may not have because I was rambling, is keyboard and mouse were originally intended to be a little bit smaller than what I have here, and it was supposed to fit inside an indent. Well, that wasn't going. Now, another developer oversight that I'm having with this project right now, actually, is that every time I bump this cable here, it reboots. So I kind of got to be a little bit careful about that, because I may be working on something and I don't want it to reboot and then lose all of my progress. But where was I? Right. Another oversight that I had with version 1.0 is that there was no way for me to comfortably fit a Bluetooth keyboard and touchpad combo in like the indent that was in this bottom half here because of all the other cabling and boards and how I have this propped up on a standoff just because of how that was implemented. So I'm still trying to rack my brain of how to take a keyboard interface like this and just plop it in there. So yeah, that's something I'm currently working on. Another issue that I had, and this was like version 0.0001, like this is the first thought that came through my head, was I'm going to build a power supply. And I did this by taking three 18530, I think they're called. They're batteries that are very common in robotics. And I strapped them all together. I wired them all together carefully. Do not apply an excessive amount of heat to batteries. They will explode. That is a very bad thing. Could cause harm to your person. Thankfully, I didn't have to learn that the hard way. I was very cautious with getting these batteries all hooked up, and I had to wire them to something that's called a battery balance board or something like that. It basically takes all of the inputs for the battery and tells the computer, hey, these three batteries, they're actually one. They're just one big power source. And then I took that, and I had to wire it to a power switch. And then the power switch was wired to the Raspberry Pi, and it worked great for all of 5 minutes. What I didn't realize is that my soldering job and the quality of the battery balancing board weren't very high. So as a result, after like 5 times of me giggling like a child, turning it off and on, I heard a pop. And I blew the board. Now, maybe it wasn't the quality of the board that caused the soldering to kind of, come undone and then catch another circuit. But thankfully, it did not harm the batteries or the board itself. It's just the balance board, the soldering pads came undone, and it just broke the circuit, essentially, so that the power switch didn't do anything anymore. So I abandoned that approach. These are just a couple of examples of development oversights, and they're completely natural, because when you're making something like this on this scale, you aren't expected to think of everything right off the bat. You're going to think of the most prominent things, and then you're going to discover later on, there's a couple of things that I forgot about. Like, for example, I don't think this has dedicated sound yet. Actually, no, I am sure that it doesn't have dedicated sound yet, because the AV, no, that's video. The only way for me to output sound would actually be through the 3.5. So, you know how laptops usually come with speakers? This one here needs speakers installed. Otherwise, I'd have to plug in headphones to hear what's going on. And this is an interesting tidbit that I came across at a hackathon, actually, because this isn't my main computer by any means. I hope that was made clear when you looked at it, but I do not take this with me to classes. What I do use this computer for is I take it to hackathons, kind of like Can't Hack Enough, represent, and I develop my project exclusively on this machine as an added challenge of do-it-yourself software on a do-it-yourself laptop, that kind of idea. And, well, one problem that I came across is while I was developing a game with my friends, we were developing a visual novel, which has all the elements of a video game that you would expect a game to have. It had arts, background arts, it had main menus, and a soundtrack. And I was the lead programmer for the project, and I kept getting sound files from our person who's making all the music and making all the selection sounds for us and the sound effects. And I couldn't listen to any of them because for me to shove like a headphone in here and then unplug it and then plug it into another computer, it just became a hassle. So I decided to use another computer to listen to all the sound files as they were sent to me, and then I would give them the thumbs up stamp of approval, come back over to this computer, download it, knowing what the sound file is, and then play it. Now, how did I test whether or not I implemented the sound correctly in the game? Well, I took the whole game when we completed a certain phase of it, and I took it and put it on another computer, a Windows computer. Now, because this Raspberry Pi runs Linux, I did run into a couple of issues with compatibility, but they weren't major. It was more or less the file systems were different, so I had to format something that agreed with both a Windows file system and a Linux file system. And this is getting more so into the game development story than it is about this project, so I'm going to reel it back in here. So oversight's natural. It's all part of planning, lack of planning, and revising your project. You're not going to think of everything, and that's the beauty of project development, is that there's always going to be something to work on. Your objective is just to kind of reach a point where you feel satisfied with what you've done. The last phase was presentation. Now, when I presented this project, I was in a situation where I couldn't win an award or anything for it because I was the organizer for the event, or that was where this was originally conceived, was a hackathon that I organized. But when I took it to other hackathons and developed my project on them, the reception was generally, this is the project? This looks great. And I'm like, no, there is software on it. I want you to look at that. This is just aesthetic. This just adds to the appeal. And I had to make it very clear that this is just kind of a thing that I do for inspiring awe. That's not the correct word. I'm undecided whether I'm just going to upload this as is or chip and chop it and edit it to make it all pretty. We'll see. This is supposed to be a substitute for a live stream, so what would be a live stream substitute without, me mishmashing words? So, to recap, because I feel like this me droning on and on has gone on quite a bit here. I started with an idea. I wanted to do something that isn't commonly done, which was build a computer. Already done it. Now I want to do something that is even less common than that. I want to build a laptop computer. That was the plan. That was the motivation. And then from that point forward, I decided, what resources do I need? How am I going to implement this? And how am I going to arrange things appropriately so that the plan matches up with the design, and the design later becomes the implementation. Another important note that I should mention, this entire case is 3D printed. I didn't make this by chopping up pieces of wood. This is all PLA, and this isn't the first time this case has been 3D printed either. As I mentioned, I had to reorient some of the I/O. So this bottom part has been printed, I want to say, at least 3 times. And I've reprinted this back plate here a couple of times to accommodate for different screen sizes. So again, oversight, solving problems that you didn't know you had. After your planning, the implementation phase kind of easily blends into it as it becomes, you've got your call to action, you figured out what you want to do. So now let's actually do what we want to do, and that's the fun part. That's why we do projects. That's why, we build things, we draw, we write, we create. It's an opportunity for us to, express our intellect and creativity. So the implementation part is very exciting. It's the funnest part of project development. And after that comes to a close, you've reached a point where you think, yeah, I like this. I made this. Look at what I made. You then go into presentation, which is exactly what I just said. Look at what I made. And during your presentation, you want to not really downplay yourself, but you don't want to be too honest either. Just let them get the general gist of the effort that you put in to make this a final result, or a final result for the time. Here's what I've done. Here's how I did it. Try this, and give them an opportunity to interact with it if you can. And if you feel uncomfortable with them, interacting with it, or you don't have a demo set up to where they can play with it in a controlled environment, then show them how you would use it, and explain, the little quirks and bits that you still need to fix. And in my opinion, I think that's project development in a nutshell, just like those 3 phases. If you think I'm wrong and I've just rambled for 30 minutes incoherently, by all means, tell me what you think. Also, if you have worked on a project that you would like to talk to us about, or even record a video of yourself talking about your project, kind of like how I'm doing here, we'd love to see it, and we may even, kind of show it off to other people who are interested in Makerspace Night as a way of motivating them to make their own projects, because that's what Makerspace Night is all about, finding motivation to start a project. This has been Anthony with Oak Hill Collaborative. I'll see you guys next week. Hopefully we'll have Makerspace Night as usual, or if we anticipate a very low attendance, as it has been the past couple of weeks, I'll see you all online again next week. Bye-bye.